So in order to graph a set of data, we first have to put the data in. So the first thing we do is we type the quantity we measured, so that's the time, and we put in the units we measured it in, that's in seconds. And then this was the position of the person that's running, and that was measured in yards because we did it on the football field in our case. And then we're just going to put our data in here just like we collected from our data table. So I'm just going to go ahead and do that quickly. So there's my data. In order to graph my data and find a mathematical model, which just means a pattern for my data, first of all, I highlight the data, and whatever's going to be on the x-axis has to be first. When I go to that, I go to Insert, Chart. Google will now take a guess at what kind of chart I want, and it actually got it wrong. So up here, where it says chart type, you've got to make sure it says scatter plot. So you might have to scroll all the way down to where it says scatter. We want to make sure you have a scatter plot, and you'll know you have the right plot when it actually plots the data points on the graph there. So now you can see there's kind of a line there. Just to make sure, down here where it says x-axis, make sure time is on the x-axis, and under series, that's the y-axis, make sure it says distance. Sorry about the construction noise. All right, the next thing we need to do is go over here to Customize, and on Customize, we're going to do a bunch of things. The first thing we're going to do is go to Series, and under Series, we're going to scroll down and hit Trend Line. This adds a line of best fit to the data. Now, we need to find the equation of that line, so we keep scrolling down to where it says Label, and we choose Use Equation. And so you can see right here, it says the slope is 1.8 and the intercept is 0. So that's what we're going to use, the slope of 1.8 and the intercept is 0. But we never leave that equation. We always change it. So now, where it says Use Equation, I'm going to go to Custom, and I'm going to write my own equation down here where it says Custom Label. So our equation is y equals mx plus b. So you can think of it like this, y equals m times x plus b, except we need to change these. On our y-axis, we have distance, so I'm going to say d. Our slope, m, was 1.8. We got that from the line. And on our x-axis, we have time, so I'm going to use t. And our intercept was 0, so I'm going to ignore that. So my math model actually looks like this. The distance equals 1.8 times the time. Okay, so there's our math model with the proper variables. I'm going to go down a little bit to legend, and under position, I'm going to tell it to put it on the inside, so that moves this legend right here inside, and I'm going to make it a little bigger because it's the most important thing we are after. So you can mess with the colors too if you want. Okay, we are almost finished. I'm going to collapse legend. I'm going to go back up to chart titles and axes. Our chart title is going to look like this. We are going to say the relationship between distance and time for a student jogging. So we always say the relationship between, and then whatever's on the y-axis and whatever's on the x-axis, and then for whatever it is. Okay? So that's my title. I'm going to go here to my subtitle, and in my subtitle, I'm going to put my conclusion. Okay? So our conclusion is this. The distance is directly proportional to the time. That's our conclusion. Okay? The distance is directly proportional to the time. We can make sure that our horizontal axis title is correct. It says time in seconds, so that's right. It's working because we had it here. We said time in seconds, so that got put here, so that's the right one. You just got to make sure you have a quantity and a unit that's measured in. The vertical axis title should be distance in yards, and that's right there, so that's good. Okay, so we are finished with the chart editor. We can close it. So here you go. This is a complete graph. You have your data plotted. You have your axes labeled. You have a mathematical model, which is an equation with appropriate variables, no x's and y's. We have distance and times. We have our title, and we have our conclusion in our subtitle. So that's what I'm looking for. So when you have that all correct for the guy walking across the football field, you'll be finished. Okay? To turn it in, you're going to click on the share link. Oops, I've got to give it a name. I'll call this lab 1.2. If you don't give it a name, it can't share it. And then this will pop up. And then right here, click here, choose Southern Hancock Schools, and then choose Editor. When you do that, you can now copy the link, and that's the link you're going to turn in on Canvas so that I can see your spreadsheet, okay? So that's what we're going to do today for lab, is analyze our data and find a mathematical model. When we say mathematical model, we mean a mathematical equation that expresses the relationship.